welcome and good evening to you all. I'm Abdurrahman Shourab. Currently, I'm serving myself voluntarily as Chair of IEEE Power and Energy Society AUST Student Branch Chapter. Apart from that, I'm also serving myself voluntarily as Branch Secretary of IEEE AUST Student Branch. It's my pleasure. Actually, it's our chapter's pleasure to welcome you all in this webinar called Power. In this webinar, we are going to talk about. We are going to hear from the speaker, from our prominent speaker, to much more about the power sector of Bangladesh, the current scenario of power sector in Bangladesh, and we will also get an insightful overview about a typical thermal power plant. And as I was saying, that our webinar is titled as Power Talk, so you might have already got an idea that we are going to learn about something that is directly related with power, definitely, right? So right now I can see we have a lot of guests and 36 participants. We have received more than 100 participants, and I believe that they will be joining in no time. And we have with us Professor Shahidul Islam Khan, sir, who is currently serving as a chair of IEEE Power and Energy Society Bangladesh Chapter. And definitely we have our Professor Dr. Tarek Ajit, sir, who is right now serving as the vice chair of IEEE Power and Energy Society Bangladesh Chapter, as well as he is serving voluntarily, and he's mentoring us. He's being actually the advisor of IEEE Power and Energy Society AUST and Branch Chapter. So without any ado, I would like to request Professor Tarek Ajit, sir, to take the virtual floor and please conduct this session. Thank you so much.
Thank you, Shurab. Assalamu alaikum. Welcome to this seminar, this webinar. In fact, today's webinar is on a brief to power sector of Bangladesh and overview of typical thermal power plant. And we are very glad to have our speaker from industry today. Our speaker is Mr. Nadir Chowdhury. He is currently the DGM operations of KEPCO 335 megawatt combined cycle power plant, and he is already here with us. So before getting to the webinar, we are very fortunate to have Shahidul Islam Khan sir with us. So I'd like to request Shahidul Islam Khan sir to say a few words to the audience, and then we will move on to the presentation. Sir, a few words for you.
Thank you, Professor Tarek Ajit. I'm very glad that Power and Energy Society is doing this webinar, net meeting, online meeting, whatever you call, because our student doesn't get the talk from a professional. We get the talk from our academia. So I request Nadir Chowdhury that whatever he tells, because he is a DGM of B thermal plant, right? So we will be specifically the students would be able to learn something about the power system and finally power plants, thermal power plant. For the student, please listen carefully and try to ask our today's speaker ask question to him so that he is encouraged and you learn something. With these few words, I thank Nadim, the host chair, and our vice chair for arranging this webinar. Please start.
Thank you, sir. Thank you, sir. So a few more words about our speaker. Our speaker, Mr. Nadir Chowdhury, he graduated from Khulna University of Engineering and Technology back in 2008. And then he was with Bangladesh for a few years. And then he moved to Electricity Generation Company of Bangladesh. And at present, as I told you already, he is the DGM operation of 335 megawatt combined cycle power plant at Meghnaghat. So I would like to request all the audience to mute their microphone so that the presentation continues without any kind of disturbance or any noise. And then another request is please keep your questions for the end of the session. So once the session is over, like once the presentation is over, then we would like to take a number of questions from the audience, because it's your questions that make the whole session interactive. So we'd like to take a number of questions from all of you, but for the time being, just please note down whatever you have in your mind so that you can ask the questions at the end of the session. So now I leave the floor to Mr. Nadir Chowdhury, and let us have a very interactive session. Thank you. Thank you very much. Nadir.
Assalamu alaikum and good evening, everyone. Thanks for having me here. And I am very delightful to being here. And I would like to take the opportunity to thank Ahsanullah University of Science and Technology, Power and Energy Society, IEEE, to invite me here. So today our topic is to discuss a brief to power scenario of Bangladesh and thermal power plant overview. So, so I designed the slide in such a way that power scenario is almost universal all over the world. So I designed the slide, it's a very vast, like ocean. So I took the process simple so that it is you can get it easily, as well as you can parallel time you can get insight of the whole power plant. So today I will try to discuss a few topics like why power engineering, number one. Number two, power plant overview, generation overview. And number three, thermal power plants overview. And number four, like I would like to take any sort of question, like it's a casual chat. I would like to chat you in person. So you can ask any sort of question, any silly question. So please note your questions, and end of discussion. Maybe I will carry out the session for 30 minutes because too long is it will be complicated. So I will try to finish the whole session in 30 minutes. And next session, as long as you can discuss with career sessions, pros and cons of power sectors. So right now the scenarios, everything, anything you can ask. So I am starting with power engineering. Why power engineering? Power is everything that makes everything possible, right? So any industry, medical sector, any sector we can imagine of. So power is the thing that make it live. So without power, it cannot be done. It's unimaginable. So you see, right now we are having three-phase AC, right? So back in 1882, so there was a war, big war of science, like DC versus AC. We all know Thomas Alva Edison, right? So he invented incandescent lamp. So then he tried to marketing DC system for transmission. Then a big war started after 1886 when AC came, when William Stanley, one genius, when invented AC transformer. Then under George Westinghouse. So the fight was in between DC and AC. It was in between, like between Thomas Alva Edison and George Westinghouse. So in Westinghouse company, so there was another genius who left Mr. Edison's company and joined Westinghouse company. He was, everybody knows his name, is Nikola Tesla. So the war started between Thomas Alva Edison and Nikola Tesla. That means DC versus AC. So finally, we know we are having three-phase AC. The world is thriving with three-phase AC. So we can ask, why three-phase? Why not six-phase? Why not 12-phase? We know three-phase generate 3 times more power than single-phase, right? So it reduces conductor. It produces 3 times power. So why don't we use 6-phase AC? Why don't we use 12-phase AC? So here comes the power engineering. Power engineering in the same time, it is like engineering at the same time, it is, invention and optimization. So when you will go for 6-phase, or 12 phase, you will need a big size of generator. Your rotor modification and stator modification need to be carried out, as well as now in 3-phase AC, we have three bus, right? RYB. So for every single phase, we use a lot of things like CT, PT, breaker, and several protection schemes. So if we increase it to 6-phase, your instrument needy things will be 6 times more. Yeah, you will get 6 times more power. Rather than 3-phase, in 6-phase you will get more power, but your overall cost will be huge. So that after several journal and several research, so it has been discussed that it's not feasible, and 12-phase is much complicated. So rather we use 3-phase AC. So eventually, under current government scheme, our right now generation is 20,000 megawatt. So 10 years back, it was like 10,000 megawatt. So we see in 10 years, it tried to 10,000 megawatt more. So right now, Bangladesh is having 20,000 megawatt generation. Maybe every day it is like 12 to 13,000 generation, and rest is sometimes due to power plants maintenance factor or other factors or low demand, we cannot maintain. So now we will see a overall view of current generation scenario of all the power plants, and after that we will see thermal power plant view, and after that we will go for career discussion, question and answers, everything. So I am sharing my slide. Let's go to the slide. Fine. So now we will discuss the amazing journey from the power plant to your doorstep, how power comes to your doorstep. You'll see there are three major sections in Bangladesh, also all over the world, three major sections in power generation and transmission and distribution. So right, you see first part is generation. First we need to generate electricity. Then with step up transformer, we need to step up the voltage for reducing transmission cost as well as reducing transmission losses. So you'll see the second step is step up transformer and build up the voltage to several kV, like 132 kV, 230 kV. In Bangladesh, we usually use two major voltages, 132 and 230 kV. And then step down transformer, it reduced the voltage to usable limits like 33 kV, 11 kV, and 230 kV. So who use 33 and 11 kV? Those are industrial customers. And 230 kV usually used in household sections. So you see, red part is shown as generation section. Here, all the power plants in Bangladesh are connected to a grid. We called it National Load Dispatch Center. So almost right now, almost 157 power plants right now in generation, and few more are yet to come in generation. They are in project phase. So red part, for simplification, red part is power plants. And you see this blue part, that is transmission line. So who transmits this power? There is a company in Bangladesh, Power Grid Company Bangladesh, PGCB. It's their task to transmit the power in several voltage level and maintaining national grid level voltage and frequency. Then this green color is distribution part. So who maintains this? This section maintained by Bangladesh Power Development Board, and under its section in Dhaka, there is DESCO, DPDC, two company. In outside Dhaka, there are Rural Electrification Board. So they maintain this section, distribution section. So in simplification, power plants generate electricity, PGCB or transmission company transmit it, and distribution company distribute it. And as a whole together, the process is running. So, and BPDB is the government authority, Bangladesh Power Development Board. So they maintain and monitor the system. So next, types of power plant. There are you can see nuclear power plant, natural gas power plant, coal power, geothermal power, hydroelectric power, wind power, solar power, then tidal power. So let's start from one, nuclear power plant. So in Bangladesh, right now in Rupur, there is one nuclear power plant which is capable of 2400 megawatt. There is 2 reactors, each 1200 megawatts. So it's in project phase. In 2022, it will be coming generation. So natural gas generation, natural gas power plant, almost 11,000 megawatt, almost more than 55% of power is generated by natural gas right now in Bangladesh. Coal power, right now, few big power plants, though rest of the world is avoiding coal power plants for, to eliminate environmental pollution. But, in practical scenario, we are having some limitations to meet electricity. That's why few big coal power plants is, in process. So there is Pyra, that is nearby Kuakata, 1320 megawatt, and Matarbari also, a similar megawatt. 2 big power plants is on the way. And we don't have any geothermal power plants because it's like in the country like Iceland, Greenland, those countries who has geyser naturally, they use those sort of energy. And hydroelectric power plant in Kaptai, we have 230 megawatt of hydroelectric power plant. Wind power plant, in Moheshkhali, where in coastal areas where there is a sufficient amount of wind, here wind power plant is installed. Right now 60 megawatt capacity power plant is there, and government has plan of 150 megawatts more to bring by 2022. So that will be in Inani Beach, that will be in Chatpur, in windy areas. And solar power plants, in Dhaka and many more places, individually some are using, and also government is, implementing or focusing more to use renewable energies. So as time is passing, so every government all over the world is, they are eliminating, dirty fuel plants, and they are focusing on, renewable plants. That is installed versus derated capacity. So you see our total installed capacity, like I said, 20,813, approximately 20,000 megawatt, and derated capacity is 500 megawatt less. So why derated? Eventually, as power plant is aged with time, so its maintenance factor increases. So power plant cannot produce up to the mark power. So, and due to substations also, they are not, power plant, new power plants are adding, but substations are old. That's why they cannot take that much power. So that is another factor. So due to that, deration happens. So that is the installed versus derated capacity. So right now we are losing 500 megawatt in the whole system. So that is the statistical view. So installed versus derated capacity plants of Bangladesh. In coal, you see 524 megawatt. In gas, 11,000 plus megawatt. And then second, we are producing electricity by HFO, high furnace oil, 5,500. Then high speed diesel, hydro. Then we import almost 1160 megawatt. That means more than 1,000 megawatt from India. And solar, that is the generation, 35 megawatt right now. So that is gas turbine. What is gas turbine? That is simply a prime mover. To rotate generator rotor, we need a prime mover. We can do it with a gas engine. We can do it with a engine. We can do it with a gas turbine, anything. Or we can do it with a hand even. So we need to rotate rotor to produce varying magnetic field so that cuts stator conductor to produce electricity. So gas turbine is simply the prime mover that rotate rotor of generator. So what does gas turbine do? Gas turbine in Earth or in space, gas turbine is used. So in Earth, all the power plants, most of the power plants use gas turbine who has a gas fuel. And what it does, it takes inlet air, then there is three major part: compressor, combustor, and turbine. Then its shaft is connected to generator rotor. So it takes air, then fuel is added, then combustion is happened, then that hot air or flue gas, you can say, that is thrown to turbine blade, which rotates with huge energy, then which rotate generator rotor shaft, and electricity is produced. And that is the exhaust system. Later on, I will come to exhaust system, that flue gas is used to heat up boiler. So that is the cross section of gas turbine. For cross check, can you hear me? I am repeating one more time.
Yes, sir. We can hear you.
Okay, fine. So that is the part. You can you check my cursor, please. That is the compressor part. That is the intermediate part is combustor part, and 3 or 4 with design, sometimes 3, sometimes 4. GE General Electric use 3 blades, and MHI Mitsubishi International use 4 blades. So as per design, and later on this is connected to rotor shaft. So major parts of gas turbine we can see later picture, that is you see compressor, combustor, and turbine. What compressor do? It is taking a fresh air, then fuel is added, it compressor does compression, then pressure is increased, that high increased pressure, pressured air is going to combustor, fuel is added, then here huge heat is generated, energy is generated, those energy is thrown to turbine blades, which does the work of rotation. So in gas turbine, what it does, it transforms chemical energy into rotational energy. So that is Mr. Breton, George Breton, American scientist, who invented this cycle. So PV and PS diagram, that is purely thermodynamics. Don't be bored, just have a look and you will understand. From 1 to 2, pressure is increased, and that actually maintains 2 isentropic process and 2 isobaric process. Isentropic means enthalpy is constant in 2 process, 1 to 2, 3 to 4, and pressure is constant in 2 to 3 and 1 to 4. So I will explain. From 1 to 2, in constant entropy, pressure is increased. Compressor does the compression, so discharge pressure increases. From 2 to 3, you see it is combustion is going on, so huge heat is generated. So it's done is constant pressure. In boiler, in combustor, the process is done in constant pressure. From 3 to 4, this hot gas is thrown to turbine plate, so that you see pressure decreases. It's an open environment, pressure decreases and volume increases. From 4 to 1, if it is closed cycle, then it comes an end here. So TS diagram is temperature versus entropy diagram. You see from 1 to 2, temperature increases a little bit, pressure increases and temperature increases eventually. From 2 to 3, combustion is going on, almost 1200 degrees Celsius, huge heat is generated. From 3 to 4, so similar, when the hot gas is thrown to turbine blades, temperature decreases, and from 4 to 1, it's coming back to cycle. So 2 isobaric process and 2 isentropic process. So all over the world, in every gas turbine, the cycle is same, the process is same. If you just understand one, it in aerodynamics, rocket engine, in rocket, in jet engine, in gas turbine, everywhere. Even Boeing also use gas turbine. The plane we ride, Boeing, it's used gas turbine. Under the wings, you will see 4 big gas turbines. So everywhere, the universal process, this is the universal process. The same thing is happening. So the major sections, let's not spend too much time. Compressor sections, combustion sections. These are 3 blades, pink sections, and red sections is flue gas. Hot gas is going out, and this is connected to rotor. See, Earth or space, gas turbine is everywhere. Like I said, rocket engine, jet engine, everywhere. even GE right now, one of the leader, which is the company of Thomas Alva Edison, that is the right now a pioneer of gas turbine, even in Earth or even in space. So similar, you see, that is the gas turbine of power plant, and that is the gas turbine of a rocket engine. Just everything similar. So here only difference is in the outside. Just here in gas turbine power plants, our purpose is to produce electricity, and in Boeing or in jet engine, the purpose is to make the thrust. So combustion, then flue gas is passed in such fuel nozzles in such a velocity that it makes a huge thrust that keeps the plane to the forward, and also that gives more thrust in jet engine and more thrust in rocket engine, similar everywhere. Also, that also generate electricity here, which is used in Boeing and some other things. So that is the gas turbine operation. Let us see. Let us see from here. So how a gas turbine works.
Air. A lot of gaseous molecules floating all around us. It's great for breathing, and it turns out it's great for getting lights turned on. That's because air, along with abundant natural gas or other fuels, are the ingredients that combine in a gas turbine to spin the generator that produces electric current. If you follow the electricity you use at home or at work back through the power lines to your local power plant, you'll see that the process most likely starts with the work of the gas turbine, the very heart of the power plant. First, air is drawn in through one end of the turbine. In the compressor section of the turbine, all those air molecules are squeezed together, similar to a bicycle pump squeezing air into a tire. As the air is squeezed, it gets hotter and the pressure increases. Next, fuel is injected into the combustor where it mixes with the hot compressed air and is burned. This is chemical energy at work. Essentially, this is what happens in your family car's engine, but at about 2,900 times more horsepower. Actually, it's exactly like the turbine engines on jet airplanes. The hot gas created from the ignited mixture moves through the turbine blades, forcing them to spin at more than 3,000 RPMs. Chemical energy has now been converted into mechanical energy. The turbine then captures energy from the expanding gas, which causes the drive shaft, which is connected to the generator, to rotate. That generator has a large magnet surrounded by coils of copper wire. When that magnet gets rotating fast, it creates a powerful magnetic field that lines up electrons around the coils and causes them to move. The rotating mechanical energy has now been converted into electrical energy because the movement of electrons through a wire is electricity. In what's called a combined cycle power plant, the gas turbine can be used in combination with a steam turbine to generate 50% more power. The hot exhaust generated from the gas turbine is used to create steam in a boiler, which then spins the steam turbine blades with their own drive shaft that turns the generator. What you end up with is the most efficient system for converting fuel into energy. And that's your GE Gas Turbine 101.
So let's come back to my slides. So for sound effect, we went to Chrome. So what it said, like flue gas, you see, now that is gas turbine. So when it comes to a combined cycle power plant, we have gas turbine and steam turbine. So what does gas turbine do? It produces power. It uses gas turbine as a prime mover. Then flue gas is, if a power plant is not a combined cycle, we call it simple cycle or single cycle. So flue gas is thrown to emitted to environment. But that is a huge heat loss. So what does a combined cycle power plant do? That utilizes that heat. So, and it uses that exhaust gas into HRSG to heat up water to a certain temperature and pressure, and that produces steam that rotates steam generator blade, and that is also connected to another turbine, another generator, so that we combinedly achieve huge power. So in right now, most of the power plants, they are turning into combined cycle because nobody wants to lose efficiency. A combined cycle power plants that can achieve up to 60% efficiency in single cycle, we can achieve to up to 35 to 40% efficiency maximum. So here is that is the combination of a Breton and Rankine cycle. So George Breton, we discussed earlier, and Rankine, that is also American scientist and inventor. So he invented the Rankine cycle. We will discuss it later. So come to boiler or HRSG. HRSG, we call it heat recovery steam generator. So flow gas from gas turbine that is passed through that heat recovery steam generator HRSG, then in which water tube are installed in such a way that when flue gas with huge temperature passes, almost 600 degree passes through the HRSG, water becomes a steam, and that's a complicated process. Let's make it simplified. There are HRSG function is to produce the steam. So that steam is thrown to turbine blades. So here we will see how steam turbine works. So steam turbine works in Rankine cycle. You see in upper diagram, that is one which extracts water. That is a big, water reservoir. We call it condenser. Then condensate pump. Then it pumps water from condenser to HRSG, which produces steam from water, and that water is thrown to again steam turbine blade, and which converts that heat energy into rotational energy. So with that shaft, steam turbine generator is connected, rotor is connected, so that also produces electricity. So if we see right side diagram, that is the typical steam turbine rotor. So those are the blades through steam is pass away, and this rotates, and that also acts as a prime mover of steam turbine rotor. If we see Rankine cycle, that is a temperature versus entropy curve. So from 1 to 2, temperature little bit increase because pumping water from reservoir condenser to HRSG, it's a little bit heat increase. In 2 to 3, HRSG, it's a boiler, huge heat is generated. You see curve is exponential. And from in this flat line, you see that is in a phase, up to a phase, water, up to 100 degree, water stays water. And above 100 degree, due to latent heat, and water becomes a steam. And you see the point at which it becomes steam, we call it critical point. So it is also called as a vapor extraction cycle. So that is just purely thermodynamics, what happening in the cycle. And from 3 to 4, you see pressure and temperature decreases. It comes to condenser or reservoir, whatever you say. So that is the simplified diagram. Actually, it maintains a lot of things. We call it as a heat balance diagram. A lot of equipments are there, so that is a more simplified diagram. So a lot of electric, a lot of mechanical, a lot of thermodynamics discussion. We have already, maybe we have become bored. Let's come to electrical discussion. So power triangle, that is, in power generation or for any synchronous generator or for any electrical power system, that is a basic thing. So what makes power triangle? That three things, that is in x-axis, real power, in y-axis reactive power, and apparent power, the root sum square of real power and reactive power. So what is real power? Real power is like everything that consumes electricity. You see, any sort of electricity we use, you know, lighting load, fan load, AC, refrigerator, any sort of things that consumes electricity, that is real power. Even motors also. Motors are the big load of real power. And reactive power. So that is in power system, that is the most, you know, lot of confusion goes around with what is reactive power. Actually, generator needs to generate real power. Why it generates reactive power? So reactive power, you see, for reactive power, worldwide, a metaphor is used, that is beer glass metaphor. So let's we don't use beer glass metaphor. Let us use 7-Up or a Sprite metaphor. So you see, when you open up a can of 7-Up, a lot of fume comes out. You know, pressurized CO2, pressurized carbon dioxide. So we cannot that liquid part is called actually active power, and that foam part is called reactive power. Without foam part, that actually integrated in the liquid part. When you open, then it becomes foam, but it is required for system. And combinedly, that liquid part and that foam part, we call it apparent power. So now let us come how it is generated. Reactive power is generated, you know, due to varying magnetic field. When rotor rotates, due to varying magnetic field, as per the laws of induction, rotating magnetic field cuts stator conductors. That's why electricity is generated. And as per Lenz's law, we know that voltage is equal to minus n d phi by dt. So it try to oppose the cause of generation, the creation. So the flux is generated, it try to oppose. So Lenz's law says that. So what reactive power is, like any synchronous generator, we give excitation, DC excitation. So DC excitation means rotor is excited, it produces magnetic field. That magnetic field, that magnetic flux, when, you know, prime mover rotates, rotor also rotates, that becomes varying magnetic flux. We use DC instead of AC because we want uniform magnetic flux. And when we rotate rotor with, you know, prime mover, it becomes varying magnetic flux, a smooth varying magnetic flux. And when it cuts a stator conductor, it produces megawatt. It also produces megavar. The megavar, we call it reactive power, and megawatt, we call it real power. And together, we call it apparent power, which is root over of megawatt square and megavar square. We call it, we measure it as a volt ampere. So that is also a measurement of power factor. You see, power factor is like real power by apparent power as per the images. So power factor is very much important in power system to maintain grid voltage, to maintain overall flux in the grid. Overall, you know, in grid, real power is consumed by all of our loads, and reactive power, who are the consumers? Who consume reactive powers? Reactive power is consumed by transformer, you know, in transformer primary and secondary core. So in between primary and secondary, there is, you know, we need to magnetize the core. So reactive power does that part. In induction motor, you need to give, you know, induce electricity, right? So when you put electricity in stator part, you know, three-phase power, that time it generates magnetic field. That is reactive power. That reactive power is necessary to produce torque. That's why torque engages in rotor part. And apparent power, that is combined power. Okay, let's forward. In synchronous generator or alternator, we call it, another name is alternator. So we have already discussed what we do in synchronous generator. Like earlier, we have discussed with gas turbine, which is connected to a synchronous generator rotor. Here is the rotor, that inside portion, that is rotor, that is excited with a DC excitation. And in stator part, we keep 3 coils like in 120-degree phase shift. So that the waveforms generated, a uniform waveforms you see are YB, red, green, and blue. So every waveform lags each other by 120 degree, so that three-phase power is generated. So in stator part, like this part, we get megawatt and megafarad, and we can vary in real scenario when grid demands. We vary the excitation. We vary the excitation so that far or reactive power we can control. Also, how we control megawatt? Megawatt we can control with limiting fuel. We can increase or decrease. Modern power systems, those are very much automated, very much smart. A gas turbine can take care of itself. So controller take care of itself. We just give command. But behind the scene, what happens while I try to reduce reactive power, excitation voltage is reduced, excitation current, the magnetization is less. That's why flux cut is less. That's why less power is generated. So that is synchronous generator capability curve. So all over the world, any power plant, any synchronous generator, that is the basic thing what happens. So we need to run. So that is universal for any of the power plant. So if we run a synchronous generator, we need to run it through a limit. So what are the limits? So one by one, I will try to explain. So you see, if you look at the picture, in y-axis, there is reactive power, megafarad. And in x-axis, there is megawatt. So, there is one term in power system, load angle. That is a angle in between generator EMF and terminal EMF. Generator EMF is, always little bit more than terminal EMF due to resistance or impedance. So with that concept, if we, that's a big concept. You can see Lucas diagram in YouTube. It is very much easy. If you search how to draw capability curve in detail, explanation is there. But in power system, what you need to understand is to run the generator within this limit. So what are the limits? Like if you see this curve, megawatt, if you follow my cursor, that is stator winding limit. So up to that limit, we can produce megawatt. So in positive y-axis, that is reactive power, positive, that is lagging power. So if we are in positive y-axis, we are giving VAR to the system. And if we are in the negative y-axis, we are consuming VAR from the system. That means we are drawing VAR from power grid, in national grid. So always the concept is you need to produce megawatt and megavar and give it to national grid, so that other consumers like big industries, they have motors, even household load also, there are capacitors, inductors, those consumes reactive power. Inductors consumes reactive power as a magnetizing current. It stores energy as a current, and capacitor stores energy as a voltage. So what does reactive power do? It to and fro in the system. It's consumed, again it's released. It consumes, it's again released. So it runs to and fro in the system, and it acts as a carrier of real power, megawatt. So that how much excitation we can give a generator. That blue curve, positive y-axis, that is over excitation limit, and in negative y-axis, the red curve, that is under excitation limit. So we need to run generator in between this. What happens if we go beyond that curve? That if we go beyond under excitation, generator will shut down. It will happen, pole slip will happen. There are lots of protection in generator, electrical protection. One is pole slip, it will lose synchronization. And what will happen if over excitation is given? So your rotor coil that will be heated, your generator life will be damaged. It will be less. It will be weary and teary situation, over excitation. It will put impact on rotor windings. So those two are shown just as a example that at any point how much megawatt and megavar is strong. So we will always try in the positive y-axis to run the generator in lagging side, so that we need to always deliver electricity megawatt and megavar in the grid. So almost end of my slide. That is the thing, integrated management system. So in power plant or any industry that doesn't only generate power, that needs to follow integrated management system, which compromises of quality, environment, health and safety system. So any international industry or any ISO certified industry, ISO is international organization of standards. So we need to maintain three things: quality. So we need to produce quality power. We need to generate everything as per quality. We need to run power plants as per optimum design, and we need to look after environment also. How much NOx, how much SOx, sulfur dioxide, nitrous oxide we deliver to the environment. And not only that, the basic thing of power plant is safety over engineering. Safety first, engineering second. So we need to look over health and safety. We need to work safe, so that end of year even single incident is counted. So how the process is done? It is carried out by a cycle, PDCA. So plan, do, check, act. We need to, before working a job, we need to plan, we need to take permits, and then we need to do this. Then we need to check evaluation or performance check, that is check. Then act, means any scope of improvement. Then we again plan. That is the cycle we follow. So that is virtually it would be a pleasure if I could show you in person my power plant. So let's visit my power plant virtually. That is the aerial glimpse, aerial view of my power plants. These are boilers, or HRG you can say, surrounding Meghna River. That is the stack. Flow gas is emitted. Nearby plant is Meghnaghat 450 megawatt power plant. Those are fuel tanks. This is it. Our plant is dual fuel, so we use gas and diesel both. Summit is the owner company, but we work in TEPCO management. A Korean company is having O&M for several years. So last thing is 1 kilowatt energy, it takes a lot of complicated process to generate. So 1 kilowatt energy generation is much more complicated than 1 kilowatt energy consumption. So we can easily consume 1 kilowatt energy. We can turn off. You can keep our doors open, lighting and fan loads open, running. And so the message is like, always try to save 1 kilowatt hour energy, because it's national asset, and it's much more difficult to produce 1 kilowatt hour of energy. And thank you for having me, and it was like, I know all you are electrical graduates, but I'm also electrical graduate, but a power plant is an ocean. I try to simplify every process, kind of animation, as much as simplification, so that it give you an insight of a complicated process. Thank you.
So, Tarek, may I ask a question?
Yes, sir. Please, sir.
Yeah, to the presenter. Nadir,
Yes, sir.
I visited the power plant, your power plant, many years ago. What was the first power plant? 450 or 335? Initially,
Sir, my power plant, or you have seen in the video, which one, sir?
no. There is two. When I visited some 15 years ago with Riveris Arif, 8 person at a time. We visited 3 weeks. It took for the permission. There was one power station, first power station. Which one was this?
So you visited Meghnaghat, right?
Yeah.
So
And your son is?
yeah, I also work in Meghnaghat project, Meghnaghat power plant. My one is 335. So probably you visited 450 megawatt. That is 15 years ago. The only power plant that was here, that is owned by Pendecker Energy. That has been that ownership has been changed couple of times. That is also a multinational power plant. You have seen in the video my neighbor power plant. So right now that is owned by a Malaysian company, PowerTech. That is our neighbor power plant.
Yeah. You're right. Thank you. At that time, I heard that there will be one more power plant.
Yes, sir.
Anyway, and to Tarek Aziz, please,
Yes, sir.
if he allows, he has worked very hard. If he allows, with his permission, and always write his name, that it is Nadir Chowdhury's presentation. Keep the 15-20 slides for the students for future more explanation, because in 1 hour he cannot explain more than that. But he has explained it very nicely. I must thank you. Thank you, Nadir.
Thank you, sir. It's my honor. It's a privilege to be here.
Thank you, sir. Yes, the presentation was really nice, and I enjoyed every bit. And we actually had a plan to visit your plant, right? So Nadir visited Ahsanullah University most probably last year, Nadir, isn't it?
Yes, sir.
Sometime back in last year. So let me share one more thing. I found Nadir in my class because that time I was teaching at Khulna University of Engineering and Technology, and he was my student.
Can I pause here?
Sure.
Okay, I would like to take the opportunity to inform you all the participants, and Shahidul Islam sir also, and every single participants, that we found Tariq Aziz sir, as an extraordinary teacher, as an extraordinary person, that the whole batch is still, remember his personality and his classes. So, as a group, we are fan of him. So we found Rahimullah sir, we found Tariq Aziz sir, those extraordinary persons in that teacher, and I think it changed many persons' philosophy and styles and thinking about teacher, how a teacher should be. So that is it. Thank you, sir, for inviting me here.
Thank you so much, Nadir, for your kind words, and it always feels great, in fact, to get such appreciation from my dear students. Definitely. And I'm also very much proud to be here with Professor Shahidul Islam Khan, sir, on the same meeting and on the same floor, in fact. Let me share one more thing. Professor Shahidul Islam Khan, sir, was my BSc supervisor.
Oh, great.
And he guided me. The topic was wind integration. That time, the topic was quite new, wind integration in Bangladesh power systems and prospect of wind energy. And we actually had 3 people in the group. and he talked about. I mean, he actually shared the idea with us on exploring different, I mean, feasibility of different renewable systems to generate power for Bangladesh system. And I was working with wind, and two of my group mates, they were working. One was working on tidal, the other one was working on solar. And with sir guided us, I mean, at every stage. And at that moment, we didn't know what is publication, what is conference. We didn't have any idea. And that time, he actually guided us through the whole process. And fortunately, we were able to publish a paper which that was in World Renewable Energy Congress that time. And unfortunately, we couldn't go to that Congress, and later it was published in ICEC, most probably, with 2002 in the year. And sir actually guided us at every stage, and he actually introduced IEEE in Bangladesh. He is the founding chair of IEEE, and later he introduced IEEE Power Energy Society as well. So we are actually grateful, very much grateful. I don't have much words, I mean, to express my gratitude, in fact. So it is he who actually started all this journey, I mean, journey with IEEE in Bangladesh. And we are very much glad, we are very, very glad to have him in today's webinar. So thank you so much for being here.
You are welcome. Ask the student to ask question. Then he feels.
Thank you. Yes, yes. I definitely leave the floor to the audience, and I'm sure that you might have a number of questions. A number of questions are actually floating in the chat box. So now I would like to request Mim to take over that part and place the questions coming from the audience to speaker. I'm sure the speaker is also eager to hear from you. So thank you.
Yeah, before going to question sections, yeah, great to know about Shahidul Islam sir from Taragaji sir, and feel honored and humbled to know all the information. Thank you, sir, for your contribution. Let's go to the question part.
Okay, sir. Thank you so much, sir. Tarkaji sir, thank you. And Nadir sir, thank you. And definitely Shahidul Islam Khan sir, thank you as well. So before we move on to the question answer part, I'd like to request each of us to open up our camera, and we will have a group photo together. Though it's not possible, we are on virtual track, right? Virtual platform. So if it's possible for us, like if there is no issue or no problem, then I'd like to request every one of us to open up their camera, open up our cameras. So meanwhile, I'll be asking Arman to have some snaps. So when you are having the screenshots or snaps, please just have a count of 3, 2, 1.
Okay, we will wait for a second. 10 seconds?
Yeah, well, let us wait for 3 or 4 seconds more. Yeah, everyone should be in a comfortable position, right? Arman, I think you can go for it right now.
Yes. So I'm going 3, 2, 1. Okay, another one. 3, 2, 1. Okay, thank you.
Okay, thank you so much, Arman. So as Tarek sir was saying or was suggesting, so since I can see our treasurer of IEEE Power and Energy Society AUST Student Branch Chapter, Mr. Salman Khair is here. So I'd like to request Salman to take over the virtual floor and please conduct the question and answer session.
Hello. Thank you very much, Abdul Rahman Shura, for giving me the virtual floor. So we have a few questions for our honorable speaker. The first question we got is, what are the recent researches related to power plants improvement?
Okay.
Hello.
So we will ask one by one, right? First, listening all the questions, or one by one we will we ask Okay, first we can answer this one. So your question was, what are the area in which researcher can do research in power system improvement, right?
Yes, and in which sector the research are currently going on?
You know, though a lot of improvement has been done in last 10 years, 10,000 megawatt has been added in grid. Also, government's motto is to add more 10,000, like by 2030, 33,000 megawatt will be added in, I mean, total 33,000 megawatt will be in the grid. So, but your substation and distribution system, your grid remains the same. So you can put electricity, you can put power to the grid, but grid is old fashioned. So you need to improve grid, you need to improve your distribution system to utilize the whole power. Your hardware and software, if you use very smart software, or you very smart operating system, but your hardware is back in 1995, it cannot sync. So that section need to improve, and that is practical scenario in Bangladesh. And for research, our Honorable Tariq Adil sir did research in lot of smart grid and these sections. Bangladesh, there is a outer countries, lot of research is going on. So how to improve gas turbine efficiency, how to improve steam turbine efficiency, how to build a smart grid. Those sections are already going on. So the smallest section work is going on in the smallest section, like compressor efficiency, much more, how to use much more flow gases, how to use, in gas turbine we uses different classes. Back 10 years back or 7 years back, when I was in Shahidul or Meghnaghat power plant, Horipur power plant, that time there are class of insulation for generator A, B, C, D. That means the higher class, it can produce much more electricity. Also it can produce much more, it can take much more heat, so stability increases. So now in the market H class turbines is here. So researcher is doing much more research how much class insulation they can build, so they can increase the generator capability to the maximum of capability curve to produce electricity. Thank you.
Thank you very much, sir. We have got another question from our audience. The question is asked by Sadban Sadi. Sir, what is the potential of waste-based power plants in Bangladesh? How much power can we get in the main grid?
Yeah, that's a very nice question. I think there is a huge possibility for that one, because right now, I think last time also Dhaka City Mayor Mr. Anisul Haq, he had planned to utilize those waste management and to produce power, but that didn't turn into a finalized one. So we can try to that one, we can make that possible. Eventually in individual level, much more research is going on. That's that you are calling as biomass power plant, or with the biomass product, how can we produce electricity? That will be clean energy. The whole world is striving to clean energy. Like I said in the start of my presentation, worldwide coal power plants are shutting down. China is shutting down, India is shutting down, and Europe already shut down all type of coal power plant. So they came into renewable energies like solar, fully on solar or something like this. Also, International Space Station, ISS, it's used solar energy to all satellites use solar energy. So solar energy is huge. If we can use that one, like solar energy and also renewable like biomass, like you said, that's very that has much more prospect. Yes, we can rely on that. That's need to a combination of industry and academia.
Thank you very much, sir. I think that answers his question. We have got another question from one of our participants, Bipro De. He asked, which power plant should we use to get low rate of electricity And he also asked one more question, that is how grid isolation system works in CCPP.
Can you repeat last section?
How grid isolation system works in CCPP.
Grid isolation system
works in CCPP.
Okay. So definitely, if you consider low cost, then nuclear power plant. Right now, Rupur by 2022, Rupur is going to, start 2 reactors. But we have seen, nuclear power plant needs a lot of capital investment during during installation project. It needs huge cost. But then when once installed, the electricity cost becomes very cheap. Like in gas power plant, if I tell you practically, it takes 5 taka per unit. But in nuclear power plant, it will take 50 paisa per unit. So that will be the cost. But your initial investment will be huge. Also, if you consider solar, that is, very low cost, but your energy will be very less. A huge solar panel produces very small amount of energy. That's why, you can go to solar, but you need to concentrate. Like Denmark is now fully solar. Germany is a lot of solar power plants. Nationwide, you need to implement it. Otherwise, for a small amount of area like island, you can put solar. But for grid, I think so far nuclear is the cheapest option. Then gas.
Okay. Thank you very much, sir. And the second question, how grid isolation system works in CC? Yeah.
Grid isolation system. Okay. Thanks for reminding. Maybe he tried to ask how we isolate CCPP from grid during any maintenance or during blackout or normalized that time. If we answer based on that assumption, like a CCPP is running, now we need to isolate it from grid. So what will we do? We will shut down our gas turbine, our steam turbine, one by one, all the systems. That shutdown means our line breaker, our generator breaker will be open. So it is already connected. It is already isolated from grid. And another breaker, our transformer is still energized. That means we can take auxiliaries from transformers. That means for fully isolation, we need to open the line breaker. There is another line breaker in grid side, grid substation. We need to open that breaker. So that time we will not have any internal auxiliaries. So for running internal auxiliaries, we need to base on our internal diesel generator or something like that. But we opening that breaker, we will be fully isolated from the grid.
Thank you very much, sir, for answering his questions. And we have got another question. I think the question has already been answered, though I am repeating the question. What's the possibility or capability of waste to energy power plant in Bangladesh? Question asked by Zunaid Ali. I think sir answered the question a few moments ago, if you have heard the session. Sir, if you want to add anything else, what's the possibility or capability of waste to energy power plant in Bangladesh?
Yeah. To add something, like it will not. Yeah, it is. The waste we produce, it is huge. We can use that one. That is most potential sector. It is already left unused. So that is the much more respect for research and combination of academia and also industry. That is not a big job. Already in some rural areas, some biomass is producing electricity in some of the rural areas of Bangladesh. So for nationwide, we can take country project, big project, to make it a national, to put it in national grid. And also that is very, very expecting sector, very much more promising to bring that energy to grid.
Thank you very much, sir. I think Ms. Mazida Zafar is available now, so I'm handing over the virtual floor to her. She will continue the next Q&A and the next questions. Mazida Zafar, are you here?
Hello everyone. Sorry, my internet connection was down. Thank you so much for all of our participants to join the seminar, and thank you to our speaker for this interactive session. And there are some questions, the couple of questions that I will also ask. Okay, this question is from Rubai Ahmed. How much coal, natural gas, or petroleum is used to generate electricity in our power plants daily or monthly, and what are the sources? What are the sources?
Okay, to answer that question, coal, coal, Bangladesh has no coal. Bangladesh has a mine in Boropukuria, which is in Dinajpur. So Bangladesh first ever coal power plant. So 450 megawatt right now, but maybe 230 is right now generating. Coal also now, as I said earlier, in Paira, nearby Kuakata, and also in Matarbari, in Coxbazar, 2 big coal power plants is in project phase. So those coals, Bangladesh has such much more coals. So Bangladesh buy coals from Indonesia, China, Australia, something like this. And coal, yeah. And second question is like gas. So gas, we have our own gas. So maybe we cannot go more than 5 years with this gas, the amount of gas we reserve. And coal, like already we are importing. So we are running coal, we are planning to run coal power plants based on imported coals, and which is definitely dirty fuel, and which is not even recommended to run anymore to run coal power plants. And gas-based power plants are much more clean energy, but we are losing gas. So maybe with this reserve we can go much more, maximum 5 years maximum. That's why government is importing LNG, like natural gas, from outside of the country. And one big LNG terminal is established in Matarbari, Coxbazar. So that project is going on. So the amount of fuel, if you want to know, is different. Like the calorific value, approximate 11,000 HSV heating value. So maybe that will not be practically easy to understand that how much fuel it takes. So, but you can think with this fuel, gas fuel, we can go maximum 5 years. Thank you. Thank you, Majida. Do you have any more question from your side?
The question is it possible to supply enough electricity to the whole country through renewable energy-based power plants?
No, right now not possible. For this, you need to restructure your grid, because as you showed, as you have seen in the slide, that 55% comes from natural gas, our current generation. So that is 11,000 megawatt. Out of 20,000 megawatt, 11,000 comes from gas. And renewable energy, what is renewable energy? Like that can be renewed, like solar, like tidal, like geothermal, like biomass, like this, like wind. So yeah, government is projecting on wind power plants, like in next 1 year, another 150 megawatt will be added in the grid in Chatpur, in Inani Beach, and nearby coastal areas. Wind energy will be installed, wind turbines. And right now we have only 60 megawatt, which is in Moheshkhali. Moheshkhali is the island, so we have 60 megawatt. But a whole grid that will be dependent upon renewable energy, I think that's not feasible right now. It takes much more time, effort, also engineering. Not engineering means to restructure your grid and distribution substations. Thank you.
Sir, there is a question from M.A. Masood. That is, sir, what is smart grid, and is it possible? What is the possibility of smart grid in Bangladesh?
I would like to ask the question. I am throwing the question to Tareq Aziz sir. He may answer this. I can ask, but he is the better person. I can answer, but he is the better person. Sir, please forward.
Thank you. Thanks for the question. This question is, Majida, could you please repeat? What is smart grid, right? And what is the possibility of it in Bangladesh? So that was the question.
Yes.
Okay. So I'm taking a course in my postgraduate program, and that is smart grid. Okay. So smart grid, it's a concept. So when you say it's a smart grid, there is no fixed definition for to call a grid smart. It's just a concept. So basically, this is a future grid. So what changes you are actually going to see in future? Along with the traditional grid, you are going to experience a number of things. So one important thing is definitely renewables. These renewables will be coming into picture, and over the years you will find more and more share of renewables into the system, increasing share of renewables into the system. And next is we want to avoid this pollution. We want to reduce the environmental pollution and carbon emission. So we are planning to move towards, not only from production side or generation side, from consumption side as well. You need to think on consumption side as well. And to reduce the carbon emission, we are planning to move towards electric vehicle. You are currently using the fossil fuel run vehicles, and in future we are planning to move towards electric vehicles. So these electric vehicles will have zero emission. So and on top of that, we have demand side management. That is another issue. And these days, whatever appliance you have, you just turn the switch on and consume power. And in most cases, customers don't have any role to play. They are mostly passive. But in future, they will have their role to play in the main grid. So they can decide when they are going to consume through their appliances. So they can shift the uses from 1 hour to another hour, so that they will be paying less off peak hour. If they move the uses to off peak hour, they will be paying less. And if they're, that's how they get some benefit. And when they are moving their uses to off peak hour, that means you don't have to produce that much power during peak time or peak hours. So you don't have to run the oil-based expensive plants. So your electricity bill will definitely, the generation cost will definitely go down. So that's how the utility gets benefit. So there will be benefit from both sides, from consumer side as well as from generating or utility side. So, and to connect all these facilities, this renewable generation, and then what you say, that consumption side, this customer consumption side, we will have to have the advanced technologies of information technology and communication technology along with these power technologies. So the existing grid will face more and more interfaces, okay, of those communication infrastructures or ICT infrastructures. And with those, support of those different advanced technologies, these three, actually, information technology, communication technology, and power technology, these three will work together to make this whole system sustainable. So it's a concept, and we are actually working towards that smart grid globally. And the next question was, what is the possibility in Bangladesh? And definitely you have to work on this because future grid is a smart grid, undoubtedly. So we are working, and in most of the cases, this is at research level. You might know the power cell. This power cell has got a dedicated body for research, EPRC, and they are funding each year for doing research on this area, these renewables and smart grid and everything. So hopefully, I mean, in most cases, these are at what do you say, at research level, but you can see some applications as well, because the vehicles, the hybrid vehicles are coming, and then the renewables are getting connected into the system. So we are definitely slowly moving towards smart grid. And that's all from my side in short, in brief, because I'm taking a course, so I can spend hours to explain, but I should not, spend hours right now. It's dinner time. So do we have a few more questions from audience? Otherwise, I mean, at this stage, I'll just interfere that we are not going to take any more questions. If we already have few questions, we can answer those questions and then try to close the session. I'm sure my speaker is already, he has been giving his speech for long, it's more than 1.5 hours, isn't it?
I want to, sir, I want to say that the questions are coming. These actually are excellent questions. Beyond my expectation, those are much smart questions, and I am loving to answer this. Also in the right side, I am watching some good questions are coming. So I am not bored. If you, that's up to you how much you can continue. I am enjoying the session.
Thanks for your support, and then we can continue. Okay, so if you have few more questions, then we can always welcome those questions. And I'm very glad that the audience are. I feel that the audience are getting a lots of interest into this topic. I mean, just from seeing the questions, these are really excellent.
Yes, I am watching in the right side few questions, just shortly answering. Rafsan asked,
please go ahead.
Rafsan asked, burning a coal produces a lot of air waste. Do you think it will affect badly on forest river? Of course, 100%. So, a big movement is going on to save Sundarban. So sometimes some things are out of our control. We can, even though we try, but those are government's affairs, and sometimes we cannot control. Definitely, coal power plants will pollute your environment. That actually affect badly forest and river, yes. And Junaid asked, is there any open source software available to enrich our knowledge about power system? Not software to enrich your, definitely there are a lot of software, there are a lot of things, tools also you can use. Best to enrich knowledge on power system, you just YouTube, power system things are unseen. Electrical things are totally unseen. So how much that YouTube you can give you a good glimpse. Whenever I was in 4th year, 3rd year, when we studied machines and power systems, those we used to based on imagination. But now in YouTube, all sort of animation is given, and reading a big article. You can read, you can build up knowledge, but YouTube and 5-minute lecture is much more useful as visual imagination is there. So you can go YouTube, all topics are there. Also a lot of teachers are voluntarily sharing the knowledge. Smart grids are already answered. Yeah, so if you have any question, please ask.
So there is a question from Tasin. How much overload your power plant faces daily? Did we get that question, Nadir?
Yeah. So yes.
We already answered, right? Oh, okay. Sorry, I missed that.
Got the question. My power plant or any other power plant doesn't overload means in power plant. Overload means you have 230 kV grid, your transmission end, also your auxiliaries are 6.6 kV, 400 volt, different motors, etc. So overload means it can be used in different terms, like your line cannot be overload because it's designed that way. It can take 8,000, 9,000 amperes total load it distributed through that transmission line, overhead transmission line. It cannot be overloaded, otherwise your design is faulty. And your 6.6 kV bus surely is designed in such a way that it cannot be overloaded. But grid overload means maybe he meant frequency.
That's the difference.
Frequency. So
that's beyond the plant. That's beyond the plant.
Beyond the plant. That's beyond the plant. That's in the grid side. That's in the grid side. You'll see. If I answer this in such a way that frequency grid is something like that, you are putting some nozzles to fill up a bucket, and you are also draining that bucket. Your target is to maintain 50% water. So you are already filling, you also draining something. The drainings are like distribution, and they are distributing electricity, and fillings are like power plants, they are filling. So grid balance in such a way that frequency remains around 50 hertz, and there are protections. So above 51 hertz, 51.5 hertz, few power plants, a lot of power plants will trip, and below 48.5 hertz, a lot of power plants will also trip. There are protections. So the PGCB, National Load Dispatch Center, maintains, they are the responsible for this action.
Well, there is a question. There is a question from Fabliha.
Yeah.
The question is about the environment for women in power. Women in power plants.
Yes,
so
right.
she just wants to know some experience.
Yes, I am glad to have that question from Fabliha Alta. Okay, that is actually a very practical question, very nice question. Now, girls are coming in, if I telling you practically in BPDB, from our batchmates, a lot of girls are working in project phase. They are sitting in Vidyut Bhavan. That one is Motishil. They are, for women's, you can work technically fully in power plants, no problem. Power plants.
Exactly.
You can work in head office. You can work in power plant field level. Also in field level, we have experienced some girls also. So they are actually, I like to salute them. They are coming like electrical maintenance, instrumentation and control. Those department they are coming, but maybe mechanical engineering, that is heavy work. That is not to be frankly, as this session is a casual chat, I would like to put you the right answer. So maybe mechanical engineering, it follows. You can come, but there are works like civil and mechanical works. Those are open fielded work and heavy loaded works sometimes. So yes, much more. I encourage girls to come in instrumentation and control and electrical maintenance department. Also in head office, you can work with in the much more with management team also in the head office, and there are lots of training sessions that will be carried out through you.
Exactly. We have number of alumni from they're working in power sector.
Yeah.
The female students. A number of female students are actually working. They are now alumni and they're working in power sector.
Yeah.
And they're doing really great.
Yeah. Yes,
and so we have one question is there since that's from Rafsan, and since burning of coal produces a lot of air waste, do you think it will affect badly? Definitely, that will badly affect forest, undoubtedly.
Yeah. I have already answered that. Also, big movement is going on against Rampal power plant. You already seen under the leadership of Dr. Anu Mohammad sir, a big movement is going on. So some things are beyond our control. So some are government policies. So yeah, definitely we should not encourage coal power plant, and as rest of the world is shutting down coal plants.
Well, there is another question from Kamrul Hassan. What is microgrid? May I answer this one?
Please, sir. Please.
Okay, so microgrid, you can check the name. It's called microgrid. So it's definitely at some small scale. So what you get in grid? You get some generators, some transmission distribution systems, and then loads. That's how you form the grid, right? So when you say this is microgrid, everything is there, but in a small scale. So it has its own generators, but at a small scale. So it could be solar plants, or It could be some diesel units, okay, but at a small scale. And then it has got its own distribution network. There is no transmission network because it's a small scale, so it has got its own transmission network. And then finally it has got its own loads. So small loads, mostly residential loads. It could be residential loads. For industries, they could have their own microgrid with own set of generators. So that is industrial microgrid. So that's what we call microgrid. And whenever there is some problem in the main grid, and we try to save our systems, save our portion of a large systems, then if your portion has got some generator, then you can easily get disconnected from the main grid where some disturbance is occurring, and then you can save your own systems. So that's why we are thinking of microgrid. That microgrid could be one answer to avoid these large disturbances. I mean, to get rid of these large disturbances, you can still serve your consumers if you have your own set of generators and everything. And then I think that's what we can answer in short for this, what is microgrid. And
yes,
Professor
thank you
Shahidul
so
Islam
much.
Khan
Thank you so
there.
much. Thank you so much for answering that one, sir. You answered lovely. And Abdullah Arman, sir, here we are importing material for generating electricity. Why not importing direct power from neighboring country? In fact, we are actually importing, like I said, 1134 megawatt. We are importing from India right now from a high voltage DC line. And also, you see that is in the wing of Veramara site. That high voltage DC is converted into AC, inverter. So that mechanism, it is connected to national grid. We are actually we are importing. So we actually now maybe the thing is we are importing material. That cost is, that there is cost there, but importing electricity also, that don't give you that much, free or that much. Everybody have their own interest. So right now, almost 1200 megawatt we are importing from India, and maybe in future we are already self-dependent. Maybe in future we don't need to buy anything from any person. And also, Basirul Fahad, he asked, in 2014 there was national blackout in Bangladesh for some hours. Would you explain the technical issue for blackout? Yes, that's a nice question. 2014, the same reason, the same thing. That time, just as I said, 1200 megawatt almost we are importing from India by high voltage DC. That line, actually there is a converter and inverter system, like UPS system. They are giving us high voltage DC. We are converting it to high voltage AC, and then we are putting it to grid. That time there is a fault in converter, but that grid is connected to Ashganj. And when that grid failed, that converter failed, and inverter also failed. That time, what was supposed to do, their breaker was supposed to open, and that 1200 megawatt, is small to grid, but that actually tripped nearby power plant like Ashuganj. Then it came to RPCL, Mymensingh. Eventually there was a chain reaction in the plant, and eventually all electrical protections one by one, in a series, one by one, like a series bomb, one by one power plant tripped. That time, when Chittagong division gone, Dhaka couldn't hold. When Rajshahi gone, Borishal couldn't hold. So we have only one single grid. We don't have multi-grid. So one grid, all power plants are connected, and still vulnerable protections are there. So grid couldn't hold that time. That is the question. The route was India, like that 1200 megawatt system failure.
Okay, so I believe we are at the end of the session, Nadir. I don't see any more questions, and so we are at the, just one more question from Fahad. Why there is HVDC not AC in importing purpose? Let me explain this. When you convert the power for exporting into DC format, then you get all the problems you have in AC format. So the whole country who is actually importing exporting the power, say India is exporting power to our country. So if they have any problem with their frequency, I mean, in their operation, if they have any problem with frequency, that could be, I mean, a very severe one. And that frequency fluctuation could result into widespread blackout. Okay, so if there is some sort of fluctuation in their operating frequency, then that fluctuation in frequency is never transmitted to our country, because we are converting that frequency into a 01 DC. Okay, so DC doesn't have any frequency. So you get rid of all those problems you could have by importing HVAC when you are adopting HVDC for transmission. So you will find that in most cases, wherever the countries are actually importing power from neighboring countries, they prefer this mode, HVDC mode, because in that case, you can avoid any anomalies in power system operation in the neighboring countries. So that's why we actually prefer HVDC, not HVAC.
Yes, sir.
Isn't
Thank
it?
you.
Nadir, am I
Yes,
okay?
sir. Exactly. That
Okay.
much more. That nothing can be much more accurate than that. Thank you, sir.
Okay. Thank you. So thank you very much. I mean, especially my speaker today.
So
And
I would like to say one thing, just as I actually was, fascinated to get all these sort of questions. This actually are quality questions, and actually I felt pleasure being in the chat. Also, if somebody asks like what are the pros and cons, I asked one question that is if that was supposed to come like what is the pros and cons if I want to power sector. So pros advantage are like power plant is like an ocean, like beyond academia. In academia you are connected to your own subjects like electrical engineering, mechanical engineering, anything electrical. There are thousands of topics you can attach to that system, or you can research, you can have PhD, and if you have have planned for coming to industry, then I think power plant is the best site, because if you like problem solving, problem solving is a fun. Any type of troubleshooting is fun. Any type of problem solving is fun. Even in your household, any type of troubleshooting gives you that pleasure. So power plant, there are electrical system, process system, mechanical, chemical, everything is an integrated system. But you can see thousands. You can pass whole day with synchronous generator. You can pass whole day with there's a mechanism or troubleshooting of induction motor. So as power sector is booming, government is having huge plan on power sector. I think power sector in last 10 years has boomed tremendously, and also it has planned for next 10 years also. So if you choose, if you like analytical, if you have analytical skills, if you like to diagnose any problem, if you like troubleshooting, and also if you like to stick with your academic study, I mean most of the study, in Bangladesh, very few jobs you will get that stick to your background studies. Your tracks will be changed. But in power plants, it's an ocean. You can pass whole day. You can pass whole day with instruments. You can pass whole year even. One single, you will be made to see how much it attracts you, that you can pass night after night with some logics, with some controls like this. So that is number one, your academic attachment with your professional experience. Number two, it pays you good right now, the most important thing. Right now, if you choose any industry, I think if you consider about salary, power system is good, power sector is good. And among power sector, there are three segments, as I said: generation, transmission, distribution. I would suggest you to come to power plant because it is the mother. Because if you consider a tree and its root is the power plant, then branch, then it goes to side wings. So if you know power plants, it produces megawatt, and produces megawatt. You are powering civilization. That is a good feelings you can have. So power plants. But if you go to distribution and transmission companies, you can do. But I would suggest you to come to power plant first. Then you can have a mother mother idea of the whole system. So that is thing. And second thing is payment is good. So beyond academia, if you like to choose your career in Bangladesh, you can choose power plant, and that is the pros. And cons, what is the disadvantage you can have? So in power plants, you will miss your holidays sometimes, vacations, government holiday. Even in last 10 years, I availed 50% in with my family and 50% in power plant. That is very normal. So you will have to take it practically in your mind that is this worth of taking the chance? So just these are the pros and cons. Maximum you will lose government holidays, and this if you go maintenance, sudden call will come to attend, and if you come in operation, you have to do shifting jobs. So that is the thing. So considering all the pros and cons, you choose wisely. If you like to come in power plants, all cards are open. So that is the thing. I thought I need to share this. Thank you.
Thank you very much, Nadir. We are actually at the end of the session, and at this stage, I would like to request Chair of IEEE AUST Student Branch, Shifa, to deliver her speech, and then we can get to the conclusion of the session. Shifa, are you available there?
Yes, sir, I am available.
Okay. So,
thank you so much, sir. Thank you so much, Tarkajit, sir, and thank you so much, Nadir Chowdhury, sir, for today's session. It was really insightful, and thanks to all the participants who have been really really patient throughout this whole webinar, and we hope the webinar was also very helpful for them as well. So thanks to all for their patience and support, and thanks to IEEE PES AUST Student Branch Chapter for organizing this session. We are really looking forward to more PES events, and we are also inviting all of our participants because in future we have got a bunch of new events from PES and from IASP as well. So we hope that you all will stay tuned with us and participate in the future events. Thanks to all. Thank you again, Tariq sir. And I'm concluding this session here. Thank you and stay safe.
thank you. Thank you. See you in the next event. Allah Hafiz.
Thank you, sir. Thank you all.
Thank you, Nadir.
Thank you for having me.
Thank you. Okay. Allah Hafiz.